projects. In this video, we are going to explain about blind ECG restoration by operational cycle GANs. Introduction. The study highlights the difficulties in effectively identifying heart arrhythmias using ECG recordings due to abnormalities such as baseline drift, signal cuts, motion artifacts, decreased QRS, amplitude, and noise. The study provides a unique approach for blind ECG restoration that uses cycle-consistent generative adversarial network cycle GANs to restore the genuine ECG signal distorted by such artifacts to a clinical level ECG, regardless of the type and severity of the artifacts contaminating the signal. The suggested method was thoroughly tested utilizing one of the largest benchmark ECG dataset from the China Physiological Signal Challenge CPSC 2020, which contained over 1 million beats. Objective. The project's goal is to propose a novel approach for blind ECG restoration that uses cycle-consistent generative adversarial network cycle GANs to restore the actual ECG signal corrupted with various artifacts to a clinical level ECG, regardless of the type and severity of the artifacts that have corrupted the signal. The suggested method addresses the difficulties encountered in reliably identifying heart arrhythmias using ECG records due to different artifacts that contaminate the signal. The method was thoroughly tested using one of the largest benchmark ECG datasets from the China Physiological Signal Challenge CPSC 2020, which had over 1 million beats. Requirements. The requirements of the project are hardware requirements, software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Load Operational Cycle GANs Model. In this module, the pre-trained operational cycle GANs model is loaded into memory. The operational cycle GANs is a variant of the original cycle GAN architecture designed specifically for ECG signal restoration. The model is likely trained on a large dataset of clean ECG signals and their corresponding noisy versions. And the second module is Upload Noisy ECG Signal. This module allows users to upload or input a noisy ECG signal that requires restoration. The noisy signal could be one with artifacts, interference, or any form of corruption that degrades the quality of the original ECG signal. The purpose of the model is to enhance the quality of this noisy signal and restore it to a clean version. And the third module is Predict Quality Signals. Once the noisy ECG signal is uploaded, the loaded operational cycle GANs model is utilized to predict quality signals. The model takes the noisy input and applies its restoration capabilities to generate a corresponding restored version of the ECG signal. The restoration process aims to remove noise, artifacts, and any other undesirable elements present in the input signal, leading to a cleaner and more accurate representation of the underlying ECG. And the fourth module is Comparison Graph. This module involves visualizing and comparing the results of the restoration process. It displays both the original noisy ECG signal and the restored clean ECG signal side by side, allowing users to observe the improvements made by the model. Additionally, the graph highlights the differences between the two signals, emphasizing the effectiveness of the restoration process. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. The model is trained using the China Psychological Signal Challenge CPSC 2020 dataset in MATLAB format. And this is the MATS folder. .mat extension are files that are in the binary data container format that the MATLAB program uses. MAT files are categorized as data files that include variables, functions, arrays, and other information. Fasten GAN arc details utils are the Python files which are used in the main code to execute the project. And this is the main code file. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. A graphical user interface will pop up. This is the graphical user interface. Now click on load operational cycle GANs model to load the GANs model. So here we can see that GANs model is loaded. Now click on upload noisy ECG signal and select one noisy signal and open it. Now click on predict quality signals to predict the quality of the signal. So here we can see in the above screen, first image is the noisy ECG signal graph where the star indicates noise part, sudden jump or decrease in values called as noise. And the second is the GAN predicted ECG signal, and we can see in the second image, star position is showing accurate value without noise, means some values decrease from sudden jump. If there is no star in the input signal, then there is no noise. Now we will just close this. Now click on comparison graph. So this is the operational cycle GANs performance graph. On the x-axis we have the metric name, that is accuracy, precision, recall and F-score of GAN, and on the y-axis we have the metrics value. We'll close this. So here we can see that after GAN is trained, we will get the accuracy, precision, recall of GAN. Click on exit. And the final conclusion of the project is, the project concluded that regardless of the kind or severity of the artifacts, the suggested approach for blind ECG restoration utilizing cycle consistent generative adversarial networks, cycle GANs, can restore the ECG signal to clinical level quality. The method was thoroughly tested using one of the largest benchmark ECG datasets from the China Physiological Signal Challenge CPSC 2020, which had over 1 million beats. The recovered ECG signal is more effective for arrhythmiac diagnosis and has less impact on arrhythmiac beats. The proposed approach features superior ECG quality achieved by the proposed restoration approach, and the restored ECG may be used to diagnose hidden or undetected arrhythmiac episodes. The depth and complexity of the operational cycle GANs can be decreased even further.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.